The last thing we're going to do about vectors is we're going to calculate their length, and then we're going to change their length. So a unit vector is going to be a vector with length 1. So to find the length of a vector, well, first we're going to use those same absolute value type bars that we used when we were looking at the distance between 2 points. And we're going to use that same notation for the length of a vector, and the length of a vector is also called its magnitude. So the length or the magnitude of a vector is shown with these vertical bars that look like an absolute value bars. So if we go look at a vector, this vector here, there it is. If I wanted to find the length of that vector, then what I would be doing is I would be picking a point that represents the starting point of the vector and a point that represents the ending point of the vector, and I would be finding the distance between those 2 points. So back to my numbers, I can think of that vector as I can think of it as starting with at a particular spot, usually the origin, and ends at a point. And if you start at the origin, then the name of that ending point is going to be the same, going to have the same coordinates as the components of the vector. And so if I wanted to know the length, the distance between those 2 points, I would use the distance formula that we were using for points in 3 dimensions just in the last section. So there's our distance formula. And how am I going to apply that distance formula to this vector u? Well, I'm going to use that same thing, but one of my 2 points is going to be 0, 0, 0. So I've just got zeros for the x1 and the y1 and the z1. And so I'm going to have this square root that just has each of those components. So 1 is going to be squared, because that's like 1 minus 0, and 2 minus 0, and 3 minus 0. So that is going to be the length or the magnitude of that vector. Let's see, 1 plus 4 plus 9 is 14. So that is the magnitude of that vector. Now the other thing that we're going to do is we're going to use that magnitude to make a vector in the same direction of u that is called a unit vector. So I want it to be shorter. Instead of being square root of 14 long, I want it to be 1 in its length. So picture first here. So I've put in a slider again, and I've changed this vector here from being the one we started off with, the one that just goes out to 1, 2, 3, and I've said, all right, I'm going to multiply that by n. So this vector here, this is really n times u. I'm going to change that label here. Okay, so I changed the name. And now I'm going to move this slider, and as you watch, when I make that scalar change that I'm multiplying the vector u by, I get different lengths for vectors. So I can actually ask GeoGebra here, what is the length of that scalar, of that vector? So when n is 1, the length of that vector is about 3.74, which is about square root of 14. And I want it to be shorter. I want it to be length 1. So I'm going to decrease my scalar until the length of my vector is getting close to being 1. So hey, I should have, I guess I need to multiply my vector by something that's close to 0.3. Well, the thing I'm going to multiply it by is I'm going to multiply it by 1 over square root of 14. So back over to the numbers and the algebra here. So I'm going to now take that vector, u, and I'm going to divide it by its length. So what that means is I'm going to take, because this here is a scalar, when I get the magnitude or the length, that's a scalar. So I'm going to multiply each and every one of those components, 1, 2, and 3, by 1 over square root of 14. So I'm going to have 1 over square root of 14, 2 over square root of 14, and 3 over square root of 14. And if I find the length of that vector, the length of that vector is going to be 1. So this here is the unit vector. And that's basically how you take and make a vector any length you want it to be. So I'll do one more just numerical example. So let's call my next vector v. And I'm going to pick some random components for it. So let's go for 2 and -2 and 5. Now I want to find out how long that vector is. What's the magnitude of that vector? And so I'm going to use the distance formula, 2 minus 0 squared plus -2 minus 0 squared plus 5 squared. Well, that's going to be 4 and 4 and 25, and that would be 33. Square root of 33. To get a unit vector, I'm going to take v and I'm going to divide it by its length. And that means I'm going to divide each of those components by that length. And this gives me a unit vector that has length 1. And I could even make a vector with length 2. So if I wanted a vector with length 2, I would multiply all of that by 2. So I would get 4 over square root of 33. And -4 over square root of 33. And 10 over square root of 33. Okay, now that looks a little bit almost too easy. So I'm just going to check my answer and make sure that that really works the way that it's supposed to. So I'm going to check by finding the length of this vector. So that means I need to take the square root of 4 over square root of 33 squared plus -4 over square root of 33 squared plus 10 over square root of 33 squared. All right, you should start looking ahead and saying, oh, that's going to be really nice. When I square the square root of 33, I'm just going to get 33. So I'm going to get 4 squared, that's 16 over 33. Negative 4 squared is also 16 over 33. 10 squared is 100 over 33. So I'm going to get, and I have to redraw that square root to make enough space for myself here. So I am going to get, let's go up here. When I add those together, I am going to get the square root of 132. Now, 132 happens to be divisible by 33. If you pull out your calculator and divide, you will find out that when you divide 132 by 33, you get 4. Length 2. And so that's our beginning pieces of vectors. So that's all you need. That's what you need to know about vectors for today. Next time in the next couple of sections, we're gonna learn some cool things where we do things that we're gonna call a multiplication of vectors, but they're gonna do some things that are really kind of different from what you expect multiplication to do. Today's is pretty straightforward. Adding vectors is kind of what you expect. Multiplying by a scalar is kind of what you expect. And finding a magnitude of a vector is just all you need to do is use that same distance formula. So that's the stuff for today.